Okay, welcome back to part 3 now. We will pick up right where we left with summarize. So summarize is going to be how we calculate summary measures for certain columns of a data frame. And some very common functions that we're going to use to calculate these. If we were worried about the center, we could use mean and median, the spread, standard deviation, IQR, range, min, max. If I want to count the number of observations, I can use n parentheses. If I want to count the number of unique observations, I can use n distinct. So let's try this first one. So I'm going to use batting, and we'll just use a bunch of different examples. So summarize, and I'll do maximum year ID. So I want to get the most current year. So that should return 2022. I want to get the total amount of home runs in the history of the league. So I'm going to use sum of home runs. Then I'm going to use batting average. We can get a little bit fancier with our functions. So I can use sum of home runs divided by sum of at-bats. This is creating a batting average. I could also do the total number of rows, which is going to be n. So it's going to give me the total number of observations, the total number of players in the history of the league. And then actually n distinct is going to give me the total number. If I were to type player ID, that would give me the total number of distinct players. So this is just going to give me the total number of observations. And then I could do n distinct of year ID. So how many seasons have there been in the history of the league? When I run this, we get our results. So this collapses the entire data frame down to just one row with all of my different summary measures. So there's been 321,000 home runs. This is the historic batting average. That's why 300 is considered a really good mark. So if your career at 300, you've been a really good hitter. There's been this many observations, so this many different players over the course of every single season. And then the total number of years has been 152 seasons. But notice that my named results are kind of ugly, right? They just match the function. So we can actually name our results with most recent year equals. So our new column name equals the summary function that we have. And then I could use total home runs. I could use batting average, the number of rows, and then the number of years. Now when I run this, now we get a much cleaner result. And this result is actually a data frame as well. So if I were to run class on this, my result is a data frame. So I could do more operations to this if I wanted to. All right, I could pipe this into some more operations, and we're going to study that in a moment. But first, with some advanced ways to use our summary function. So to use summarize, a very useful set of functions to summarize by is going to be sum and mean. But when we do this, we're going to calculate a logical. So we're going to check for the number or the proportion of observations that meet a certain condition. So to calculate the total number of observations that meet some condition, what we have to do is use the sum function. So let's say I wanted to get the number of players, the total number of players that played in the very first year of the league. So I'm going to check the logical. Year ID equals the first year ID, so minimum of year ID. This returns either a true or false for every single row. We can think of true as a 1 and 0 as false. So when I sum this logical, it's going to add up all of the ones that meet this condition. It's going to sum up all of the rows that have true. So when I run this, it's going to give me the total number of rows that meet this condition. We could also check the proportion of rows that meet a certain condition. So rather than the sum, I want to get the proportion. So to do that, I could do first, actually, let's calculate the total number of seasons that have been greater than 30 home runs. So greater than or equal to 30 home runs. This is now going to give me the total number of seasons where there's been more than 30 home runs. And to convert that to a proportion, so N30, or rather we'll call it prop 30 home runs, we're going to use mean. So mean is going to take the average of a bunch of zeros and ones. And in essence, it's taking the proportion essentially. So it's taking the total number of ones divided by the total number that there is and giving us this proportion. So when I run this, there was 115 players the first year. There's been about 1,500 seasons with more than 30 home runs. And on average, there is about a little over 1% of the seasons. So if I were to take the total number of home runs, divided it by the total number of rows, that should give us this 1%. So that is how we use sum and mean to calculate the proportion and the number of observations. We could also be a bit fancier. So let's say I want to perform the same summary statistic for several variables. The long way that I could do this is by kind of specifying every single column. So I could do, so let's take my reds data, for example. So I'm going to filter to just the reds, and I'm going to select just a few columns. So let's say I wanted to find the sum of the total runs and the total home runs and the total hits. So I could do sum of runs equals sum runs, do a comma, sum of H equals sum of H, right? But that's going to get tedious, especially if I have like 10, 20 variables that I'm trying to sum over. But what I could do instead is use this function called across. So across, I want to calculate a function across these variables. So across runs and hits, I want to calculate the sum. So this will give me the sum for these two variables. So it calculates this function across these variables. And I just need to rerun that. Fix my spelling. And there we go. So I have the total number of runs by the Reds players and the total number of hits by the Reds players. We could also use any of those select functions that we learned for select. So I could call a bunch of columns using across, and I want to get everything from at bats all the way to the triples, x3b, and I want to calculate the sum of all of those. So I can use my block quote notation, my block column notation, and get the sum of all of these. But notice I get an error here because I need to have my concatenate function. So I concatenate all of these column names, and I take the sum over all of these, and that gives me what I want. And we can do one more. For example, let's say I want to now use my across function, but I want to sum using one of those helper functions. So I'm going to use starts with equals So it starts with a X now. So I'm going to be summing up the extra 2 base hits, so doubles and the triples. So it starts with, get the right function in there, sum. Now when I run this, it just gives me these two. So we can use those helper functions, just like we did with select, now to select variables within my across, which I'm using in summarize. So all these ideas are tying together. So there is an exercise for us to try. So next up is going to be group by. So as we saw with summarize, we can collapse an entire data set down to just a single row based on some or a few summary measures. Often, however, we want to use group by analyses. We want to do group-wise summaries. So I want to aggregate, I want to summarize for every single level, for every single group of a categorical variable that I have in my data. That is where the real power of group by and summarize and dplyr comes into play. So what we're going to do first is we're going to take our batting data. And I'm going to do this one in the console. We're going to take our batting and we're going to use the group by function. And I'm going to group it by year ID first. So this actually doesn't even change the data. So if I group this, all it does is just give me the same data. But what it does is it adds an attribute. So if I look at the glimpse now, it takes my groups and it adds a group for every single year ID. So it's keeping track of the rows behind the scene. It's still the same exact data. It's still going to be a data frame. If I were to check the class of this, still a data frame, but now it's a grouped data frame. It has an additional attribute and is keeping track of the rows behind the scenes. So it has 152 different groups. We can also group by multiple things. And in this case, order matters. So I'm going to group by year ID and let's say team ID. When I run this, I now have additional attributes. So now it's grouping by year ID, team ID, and now I have over 3,000. So there's a multiplicative effect of the groups. So for every single of these 200 and of these 152 years, I have, say, 30 teams. So 30 times 152, just making those numbers up. But that's how we get this multiplicative effect of the groups. So it's keeping track of the team IDs within the year IDs. So I have a bunch of different groups going on behind the scenes. So that's how group by changes what we're working with. Then we actually have to use that grouped data. So to use that grouped data, we can use either summarize or we'll see it with mutate as well and filter. But the main one that we're going to use is summarize. So we're going to work with that grouped data to create group-wise summaries. So the first thing that we can do is group. We'll just do it by year ID first. And then I can pipe. And notice here, we're building some longer pipes. So now I want to summarize my total home runs. This is going to give me the total home runs for every single season. So total home runs for every single result, every single group. And let's also calculate the number of players that season. So when I run this, 1871, there was only 47 home runs. 1872, there was 37 home runs, and so on. So this is like using the subtotals feature in Excel. So for every single year ID now, I have a group-wise summary. In this case, the sum of the home runs and the total number of players that season that contributed. And notice if I were to take the class of this, again, I'm getting a data frame as the result. So I can work with this data frame now by summarizing over the groups. It's no longer a group data frame. So I aggregate it over, so it's no longer grouped, but I can work with this the same way that I've worked with all my other data frames. So I could even add another pipe. And let's say I wanted to arrange this by descending year ID. Now I have the summarized data from these 3 lines, these 4 lines, and now arrange that result by year ID descending. So in 2022, there was over 5,000. In 2021, there was almost 6,000, and then slowly goes down from there. That's how we can use this group by and summarize, and then continue working with the result, same way that we have with all the other data frames. We can also group by, summarize multiple times. So let's try the same code, but now I'm going to add in a kind of second level group. So I also want to group by team ID. So when I run this, I'm going to delete this last line here. This gives me now for every single year, it gives me the total home runs for each team. And notice in the warning message here, or in the message, that it says that it's grouped the output by year ID. So if I were to run the class on this, I should get a grouped data frame. So I've aggregated over the team ID, but I still have my groups remaining that were the year ID. So my result is still grouped after this first summarize. So I could then summarize again and do summarize sum of total home runs. And I'll calculate my number of rows again. And now this gives me the total home runs for every single year, which should match what we get from the first one. So 47, 37, 47. Now, because it's based off a different rows, we're going to have a different number. So there's only 9 teams, 11 teams, 9 teams versus 115 players, 157 players, 125 players. So just keeping track of the different aggregations. And now if I were to run the class on this very last one, I've aggregated over the team ID. I've aggregated over the year ID. So this one should no longer be grouped. So if I were to run this code, it's no longer a grouped data frame. So that is how we can summarize multiple times over the different levels of aggregation. So there is another exercise for us. But what if I don't want that behavior? What if I don't want my result to be grouped? We can actually remove that attribute using what's called the ungroup function. So ungroup is going to do exactly what it says. It's going to ungroup our results. So we saw after I run this first one that my results are now grouped. So let me just run this first line. Actually, I'll run all of it. So now I'm also grouping by player ID. So at the end, I've only aggregated twice, so I still have the remaining group by year ID. So what I can do is actually run this first line. So I've grouped by 3 levels. I'm aggregating once, so I should still have 2 groups, grouped by year ID, grouped by team ID. So this is giving me for every single year, team, and player combination, how many home runs did they have? And the result is then still grouped by year ID and team ID. So if I summarize again, this is going to give me now the year ID and the team ID aggregated over the players. But let's say I wanted to skip the teams and just immediately aggregate over the years. And actually, by ungrouping, it's going to remove all of the groups. So now it's going to summarize over the years and over the teams at the same time. So now when I summarize, I should just get one row summing over everything because I removed that group attribute. So then it behaves just like the first time that we saw summarize, where it always returns one row. So that is how we can use ungroup to kind of control the results of summarize. So kind of piping that together. But sometimes ungroup can be confusing to work with. So a lot of times what we do, if we know beforehand that we only want this group by for one operation, instead of the entire pipe, we can actually locally specify how we're going to group. So to do that, we can change an argument in our function. So right now, if I run this, my result is going to be an ungrouped data frame. Just kidding. It's going to be a grouped data frame by year ID, and then I ungroup it. So my final result is going to be an ungrouped data frame. But if I know beforehand that I don't want these groups at the end, I can get rid of that and actually add a first argument here. And I can add dot by is equal to a column vector or a vector of my column names. So this is saying summarize the total home runs, summarize the number of rows by these two variables. And then as soon as you're done, automatically ungroup it. So it only keeps these groups just for this function, just for this single summarize. And in order to do that, I need to get rid of my groups. So helpful error messages, live coding. So then now if I were to check the class, I would see that this is no longer grouped because it is equivalent to calling group by, summarize, and then ungrouping. So very common practice is to just use dot by for all of our operations. That is how I prefer to use the groups. So I usually just use dot by instead of group by, just making sure that I keep track of everything. So we can also use group by with a few other functions. And the first one that we'll show is going to be with mutate, and it works the same way as it does with the other functions with summarize. So instead of mutating overall, it's going to do the calculation for every single variable, or it's going to, not every single variable, it's going to do the mutation for every single group. For each group, it's going to filter for each group. So as an example, let's say I'm taking my batting and I am selecting a few columns. And I want to mutate dot by equals player ID. So for every single player now, I want to calculate their average home runs. So we'll do round mean home runs to 1 decimal. So this tells me that this player averaged 0 home runs. This player averaged 0.1 home runs, 0.2 home runs, and so on. If I were to remove this dot by argument and run the same function, it sets a constant value to every single player. So on average, every single player over the course of the entire league history, they've averaged 2.9 home runs. But when I have that dot by argument, it does this mutation for every single row. And notice that we get some repeats. So for this player, right, he must have played 2 seasons or was on 2 different teams. Or let's see, let's find a repeat. Guess these are all different ones. But it would set, if there was repeat players, it would set the same home runs, the same average home runs for every single observation for that particular player. So that's how .by works with mutate. I could also do it for filter. So let's say I wanted to find the first year that every single player played. I could use batting, pipe this to filter, and I'll have .by is equal to player ID. And what I want to find is the first year that each player played. So I want the year ID that is equal to the minimum of the year ID for each particular level of the group. So for each level of player, it's going to give me this player started his first year in 1871. All of these players, first year of the league, they all started in 1871. This guy played his first year was in 1884. So that is how the .by argument works. If I were to get rid of that, it's only going to give me just, as we saw before, all of the 1871s. So eventually it's going to end. But when I have .by, it gives me the minimum year for every single player. So very useful. I could also, instead of doing .by, I could do group by player ID, and then pipe that along, and then use filter, and it works the exact same way. And we see we get the same result. Now I have the first year for every single player. So the last functions that we're going to learn are also going to be kind of related to filter. These ones are going to be to get specific rows of our data set. And this is the slice and the slice family of functions. So these ones are to select certain rows. So the first one, just the original base slice, is going to give us a way to index our rows. So if I want the first 5 rows, I can use batting, pass it to slice, and this gives me my first 5 rows. Another way I could do this, maybe more common with base R, is just going to be the head function. And I can do head. I can specify the number of rows that I want, n equals 5. Same thing. I could also get the last observations. So I can use tail. And by default, it gives me maybe 10 rows. So that's how we can get our rows specified by their index. But we can also use these in a bit of a fancier way. So let's say I wanted to use these in grouped data as well. So in the previous example up here, we found the first year of every single player. We could also do this with the slice functions, and particularly slice min. So slice head will get the first rows or the last rows, and if my data is grouped, it'll get the first row of each level or the last row of each level. And you can specify how many rows you want to get. So I could get the first 5 from each row. I could get the last 5 from each row. But if I change this to slice we're going to order by, change this to slice min. So if I'm trying to get the first row based on the year ID, I'm going to kind of implicitly arrange all of my observations by year ID. And I'm going to pull the first one that is listed, the slice min, ordered by year ID. But if I want to do it for every single player, I can add a group by player ID, pass that along, and this should give me, once I fix my capitalization, this should give me the same result that I get when I used my filter by. And now it's getting the first row for every single player ordered by their year ID. So it looks like my observations are in a slightly different order now, but that is the idea behind that. I could also use a by argument. So let's say I want to get the most home runs slice max by team ID. And let's say I want to get the top two. So I want to get the top two home run hitting seasons for every single team. Instead of dot by, now I have just by itself, and then by team ID. And the first argument is going to be my order by. So order everything by home run. And I'm going to get the maximum home runs for each team and the maximum two. So this should give me the home runs. The maximum for the first year, the first team was 4, and then 3, both from the same team, and then 2 rows for the next team, 2 rows for the next team, and so on. So that's how we can use these slice family of functions. So next is an exercise for you to try. So last up is going to be recreating the application, recreating the goal plots, and specifically how we use the data transformation, how we use all these functions that we know now how to use to get the data in a way to create these plots. So we're going to work with the Ken Griffey plot first. So what we're going to do is we need to create season level data. So we know that every single row represents a player for a season. We want to get the summary of that season for every single player in every single year. So we have to do this. So currently, if a player got traded, let's say midway season, he's going to have 2 rows. So 1 row for the first half of the season, 1 row for the second half of the season. So I need to sum over the player for each single season. And we're going to call this, I'm going to move to my console now, and we're going to call this season stats. So good coding practice, I'm going to create season level stats. We're going to take batting and notice it shows some objects that are also named that. I'll click batting. I'll pipe it. I need to summarize to dot by. I want to group this by player ID. So for every single player, for every single season, again, we're kind of averaging over or summing over. And the rows that I'm interested in, based on my plot, I need to get the total number of games played. And I also need to get the total number of home runs and games, and I want the total sum. So when I run this and I take a look at my season stats, it's going to give me all of the single players. So for this player, for this year, he played 1 game, 0 home runs. This player, 25 games, 0 home runs. So we're getting there. We now have season level data. And now I want to create a plot just for Ken Griffey Jr. So what we need to do, ggplot, this will be a good review of what we learned last tutorial. ggplot, I'm going to specify my data set. we can actually do operations within our ggplot. So the operation that I need to just get the data for Ken Griffey is filter. So I'm going to filter to my player ID, double equal sign is equal to Griff KE02. So this gives me, if I were to copy this to my console, this should give me just Ken Griffey Jr. data. And then what we can do, based on our plot, we have x-axis as season, so that's going to be our year ID. We have our y-axis as home runs, so that's going to be our HR. So we're going to have, remember, we need to put everything in an AES statement. So x equals year ID, y equals HR. And then to make a scatter plot, if you remember, we're going to use geom points. And in order to get these to be shaded by a data-driven feature, we're also going to add in our AES, and the attribute that we need, the aesthetic, is alpha. So we want that to be shaded based on the games. And I will also make the points a little bit bigger, size equals 3. So if I take a look at our plot right now, let's see what it looks like. So now I have all of the dots, and they are shaded based on how many games he played. So what I need to do now is add a line. To do that, my X and Y are going to be filtered down from the original ggplot, so they go downstream. And I just need to add geom line. That connects the dots. Now what we can do is add the smooth line. So we haven't seen this function before, but I'm going to do geom smooth, and I'm going to set the standard error equal to false, and that just gets rid of the confidence band. So if I have this as true, it gives me a confidence band, a shaded region around this average line, we can think of it, but I don't want that for my plot, so I'll set it as false. And then we can also give our labels. So we want to polish this plot, and we'll use title equals home runs per season by Ken Griffey Jr. And then year ID, right? That's not very user friendly. So we'll change this to X equals season, Y equals home runs. And we haven't seen this before. We haven't given labels to non-axes aesthetics. So this is just being mapped to the alpha aesthetic. So I can give a label to my legend. So alpha equals games played. And then we'll also add a theme. Theme BW. Now when I run this, we get our recreated plot right here. Perfect. So that is how we can recreate this plot. Again, we needed to create season level data by averaging over, let's say a player got traded. So next up is going to be create this plot. So there's a little bit more going on this one. So we have career level data now. So if you think about the data process, I have every single season broken out. Now I need to average over, sum over the entire season, which I already did, and then sum over all of the seasons for a particular player. So to do that, we're going to create career level data. So we're going to call this career stats. And we will call this, we're going to build on our season stats. So build on the season stats, and I need to summarize again over now. I'm going to collapse over the years. So I'm just going to summarize over my groups, which is going to be the player ID. So for every single player, total up all of their career stats for every single season. And I'm going to again use the same kind of logic. I want to sum the across the games and the home runs. I'm also going to calculate a new variable called seasons. So I want to figure out, maybe games isn't very interpretable. So 15 seasons, there's like 320 games a season. So 15 times 320, something like that. Maybe that's not very interpretable. So let's use seasons instead. So seasons is going to be the number of rows based on the player level data. And then to calculate whether or not the player is active, we'll call this status. We actually need to check a condition. So if else. So what we're checking is if they are still playing in 2022, are they still playing? That's the condition that we're going to check. So max year ID, is this equal to 2022, grouped by the player? So for a particular player, is their maximum year equal to 2022? If so, we want to set it to active. If not, we want to set them to retired. When I run this, career stats, add an extra comma, extra parentheses in there. Now I have my career stats for these guys. So obviously this first guy, we're playing in the 1800s, he's retired. And then if we scroll down to active, so these players, Albert Pujols is still playing. He played this many games, 22 seasons, and is still active in 2022. So next up is going to be to create our plot. So our plot only shows the top 500 home run hitters. So to get that, we can use one of those functions that we just learned. If you think about it, we can use plot just the top 500 hitters. And we're making a plot colored by active. That's what we want to do. So we're going to take our career data and we're going to pass that to the function that we need to use, is slice underscore max. I'm going to order by home runs, and I want to get the top 500. So this is giving me implicitly ordering all of the home runs from lowest to greatest, and it's going to take the top 500. I'm going to pass that to my ggplot. And AES, we'll just go ahead and go straight to seasons, because that's going to be more interpretable for us than games. Y equals home run. And I want the color based on the status. So based on that new variable that we created. Then we're going to create a scatter plot. So G on point. And this is what we get. So notice it gives us some default colors. So the way that we specify the colors that we want is by using the function called scale color manual for manually specifying. And all we have to do is create a named vector that is going to be for the values argument. And we just have to match up our values to the color that we want. So for active, I'll set them to forest green. And for retired, which is the data value, I will set that equal to the color gray. So for our narrative, we are focusing on the active players. So I want those to bring to the forefront and let the other ones kind of blend into the background. And then we could also run that. Now we get our colors. We could finish polishing the plot, add our labels. So title equals top 500 home run hitters. Our X is equal to seasons. That's why it's kind of grouped like this. So because there's only distinct values, 15, 16, 17, and so on, that's why we hit this vertical line pattern. And then Y is our total home runs. And then I like the theme BW just to clean it up, get rid of the gray background. And this is our recreated plot. So that is the data that went behind both of these plots, so that allows us to answer some more questions about our data set. So an exercise for you guys to try is to study this plot. So it looks like we're at the top 5 home run hitters over the past 10 seasons, and think about the data transformations that would be needed to solve this. So there's a hint for you to try. So think about each step. Think about what is the y-axis. Think about what is the x-axis. Think about any filtering, anything that needs to be done. This might take multiple steps. So think about the data that would need to go behind the scenes in order to recreate this image. So that is it for this video. Thanks for watching, and I will see you in the next section.